Good day, I am Artyom Yegorov, and let me introduce our work improving low contrast images using frequency and phase transformations. The one of the serious problems in image processing is absence of a priori info about image characteristics, which may be very different. We are talking about weakly contrasted images, and these images, instead of often used low contrast images, may contain a full or almost full range of gray levels with significant dark and light areas, a multimodal histogram, a smooth transition of brightness in regions of interest below the threshold of visual perception, and blurred boundaries between them. Intensity levels are changed significantly in different areas. Anomalies are often compared to the level of noise. Low signal-to-noise ratio and complex structured background significantly difference in quality for the same object and recording method, depending on the conditions of formation, quality of films, equipment, recording time, making the analysis task particularly difficult. In addition, we often know nothing about presence or absence of objects of interest and their position, size, form, and so on. From the left, we can see the example of such image. It's X-ray image of human face, and here we can see the histogram of this image. One of the solutions of this problem is the composite algorithm, which combines several methods. Approaches to the improvement of digital image are usually divided into two categories: processing methods in the spatial and frequency domains. Fuzzy logic usage is a perspective approach for the making spatial domain operation at present. Fuzzy logic allows to take into account ambiguity that is objectively always present in images. The reason for image ambiguity are the loss of information when transferring 3D objects to 2D space, geometric fuzziness, ambiguity of object boundaries, and so on. Transition to fuzzy representation also may be considered like transition to another feature space. For the frequency domain operation, digital Fourier transform is the obvious step which allows to change the feature space. After applying Fourier transform, it is possible to use frequency domain transformations which are based on matrix F, the result of Fourier transform usage. For returning to spatial domain after making a frequency domain transformation, we need to make inverse Fourier transform. Purpose of this work was creation and experimental researches of the adaptive composite method of low contrast images enhancement, which combines frequency and phase transformations and makes several transitions between different feature spaces. Here we can see the algorithm of proposed method. At first, we are scaling images I brightness to the range 0, 1 with following digital Fourier transform and obtaining a matrix F1. Here we are making our first changing of feature space. After that, we can use frequency domain transformation. It is shown here. And in this formula, we use a coefficient R equal to 0.8. After this transformation, we are changing our feature space again by using inverse digital Fourier transform for matrix F1 stroke with following scaling to the range 0, 1 and making adaptive histogram equalization. It gives us the image I2. After that, we are forming image I3 by this formula. And for this image, we enhance the contrast by fuzzy method. And we are obtaining matrix I4 in the result. After that, we are forming the resulting image. We used fuzzy intensification operator for contrasting our image, and this method contains the next steps. At first, we are calculating a membership function mu for image I3 by these formulas, and after that, we are modifying this membership function by this formula and obtaining matrix mu stroke. And after that, we are forming resulting image I4 by this formula. Here is the algorithm of forming our resulting image. At first, we change our feature space again by using digital Fourier transform and obtaining matrix F5. After that, we are making a matrix F6 by the following formula. Here we can see coefficient R1 and R2. These coefficients may be selected manually or may be calculated automatically by the next formulas. Coefficient L1 may be used for controlling the level of details. Moreover, it may be used as with manually selection and with automatically calculation too, because in this formula this coefficient also may control the total level of details in resulting image. After calculation, matrix F6, we are making the last changing of feature space by using an inverse digital Fourier transform and obtaining image I7. This image is scaled to array to the range 0, 1, and after that we are making adaptive histogram equalization. After that, we are getting the resulting image. Here we can see one of our source image. It is X-ray image of part of human spine. And here is a histogram. As you can see, this is a low contrast image with 2 dark areas. Here and here we can see the result of processing this image by a different methods. By adaptive histogram equalization, the result of Fourier transformation, and the result of fuzzy intensification operator applied. As we can see, only adaptive histogram equalization allows us to increase the level of details, but still this levels is not enough for visual analyzing. Because these areas are still not light, and the details of different bones of this part of spine are still invisible. Here we can see the result of applying our method. From the left, we can see the result with manual coefficient selection, and from the right, we can see the result with automatic coefficient calculation. As we can see, this image looks like similar, but this image has a little more level of details due to adaptive nature of this automatically calculated coefficients. Here we can see the result of processing one more source image. This image contains X-ray of a human face, and here we can see the result of adaptive histogram equalization and applying of fuzzy intensification operator. Both methods will not be able to give us the proper level of details. On the other hand, proposed method usage, here we can see the results, allows us to get much detailed resulting images. Moreover, due to changing the coefficients, especially R1, we can control the level of details. As we can see here, we have higher level of details with smaller value of coefficient R1, and here we have a lower level of detail, but still the level of details this and this image is still much higher than the level of details for these images. The application of composite adaptive algorithm for processing grayscale medical images, which includes the transformation of the frequency response of the digital Fourier transform and the method of fuzzy intensification. The algorithm has parameters that can be adjusted to control the level of detail in the object structure. We proposed an automatic calculation of this parameter, R1 and R2, which reduces the time required for the selection and allows achieving a high level of details without excessive detail effect. Moreover, we still able to control the level, the total level of details for all image, even in the case of automatically calculating coefficients. Researchers have shown the effectiveness of this algorithm for low contrast images of different physical nature. The usage of various fuzzy transformation methods represents a promising direction for further research. That's all, and thanks for watching.